Hello and welcome to the Streaming Video Alliance's submission to Mile High Video. And today we got two of our working groups who are going to show some of the work we're doing in the Streaming Video Alliance. To give you an idea, we're going to show you work from quality of experience and advertising, and the Streaming Video Alliance is here to make streaming video better. We collaborate across different parts of the ecosystem to make sure that we can make streaming better. And now, let's begin.
Thank you, Murad. Hi, everyone. My name is Kulbakas. Today, I'll review SVA's best practices for end-to-end workflow monitoring. My SVA colleagues will follow with real-world monitoring applications. The document is now published and can be found on the SVA website. The contributors include content owners, service operators, and monitoring vendors. The document's goals are threefold. Introduce a framework to monitor the entire workflow from source to playout, identify monitoring metrics, and correlate results to detect, delineate, and diagnose issues. Several motivational aspects are discussed. For instance, QoS and player metrics are not sufficient. Perceptual quality metrics are also needed. To illustrate, in this example, the source is coming in with high quality. However, encoder overcompression causes poor viewer QoE, yet CDN metrics and player events do not detect issues. Based on ITUT's definition, many factors can affect QoE. Motivated by this, a broad set of monitoring methods is discussed across the entire workflow. Another motivational factor is workflow complexity. In general, viewer impact is a mix of many root causes, which can occur anywhere in the workflow and may differ in nature, intensity, frequency, and time. Furthermore, impacts generally combine together as they flow downstream towards the viewer. The best practices approach aims to tease apart the impacts and delineate root causes. To this end, we propose a modular monitoring framework. Establish monitoring scope, partition workflow with monitoring points, decompose monitoring point tech stacks, describe monitoring methodology per stack layer, and finally correlate results end-to-end. This enables a variety of deployments. For example, a content owner can measure PQ at source encode and device output, a service operator can measure PQ through its AVR processing and can obtain player metrics, and a CDN provider can check QoS across its delivery. This also helps with delineation and diagnosis. In this example, PQ metrics detect impact at encoder, transcoder, and device output. However, QoS and player metrics show no network issues, and PQ is good at source. Hence, root cause is delineated to encoder compression. Thank you for your time today, and now over to Wakas.
Hello everyone, this is Wakas Malik. I'm representing SimWave, and today I would like to demonstrate how SimWave takes into account perceptual quality framework and use its real-world application to apply across video streaming delivery chain. This includes both OTT video streaming and native cable deployment. Here is a quick overview of SimWave monitoring deployment approach. It contains both quality of service and pixel level impairments and monitor across all points in the video streaming delivery chain, starting from content creation all the way up to content consumption state. The Viewer Intelligence platform collects the data from distributed software code and presents that information to the users in a single pane correlated end-to-end view. This is a reference scale for SimPlus 5-point quality bucket. SimPlus is a linear score in a range from 0 to 100, and we always recommend our customer to achieve a target quality of greater than equal to 80 for better subscriber satisfaction. Now I would like to provide a live demo with real-world example for OTT video workflow. Here's an example scenario 1 where we have 15 services being monitored across 5 points in the video streaming delivery chain. As you can see on the source, the viewer score is very high, 90.2. There's a 4-point drop at encoder, and then there's a biggest drop between encoder and transcoder output stage of 14 points. And by the time the streaming session hit the subscriber, the viewer score is 68.4 on the player side, which is way below the recommendation of 80 for subscriber satisfaction. There's also a visual representation that shows no overlap between encoder and transcoder output cut. So this view in general helps the user to trace the viewer experience right from the beginning all the way up to the end and quickly find out what monitoring point in the delivery chain is causing most of the degradation and thus resulting in low MTTR. Here is another example that highlights the issue with encoder output monitoring point. There is no issue with source in this example, but there's a 40-point drop at encoder output, which impacted all downstream monitoring points in the delivery chain. And as a result, viewer score on the player side is 38.1. This is also very obvious from the first graph on the left side that shows huge gap between source and encoder monitoring point compared to the previous example. Thank you.
Thanks very much, Joaquis. Hi, I'm Brendan from TouchStream, and I'm going to walk you through a real-world example of applying this framework to a cloud-based workflow. So as you can see, we've got a typical cloud workflow, and then what we've done is we've added monitoring to each of these monitoring points, and we've done this with a combination of our own monitoring, TouchStream's ABR monitoring for CloudFront and Media Package, and then we've added log analytics via Datadog, and then we've used Data Zoom in the player to get the player analytics out. We've combined all of that into our virtual NOC to give you an end-to-end overview built from all of that different data. And then that's what that looks like. So that's now we'll just jump into the demo, and here we are. Here's the demo, and you can see we're modeling the end-to-end workflow. This is the real data here, and we start with our own data, which is CloudFront ABR monitoring, and you can sort of see our actual monitoring. Click into that, get all the good detailed data that helps you do any troubleshooting there. Or of course we're, as I said, pulling the logs from CloudFront into Datadog, and then you can basically look at those logs and see, dig deep into them, look at the actual log lines and, all the good data about that to do any troubleshooting. We've also built in links directly to configuration tools. So again, straight into CloudFront, look at the actual configuration, look at things like case statistics, etc. Extremely useful. And then, as I said, we've built in audience metrics, and we've used Data Zoom for that, and we're pushing that data into Google Analytics, so we get a very simple view from Google Analytics of what our audience is doing. So that's all the data that we're pulling together from all the different monitoring points. Now it's over to Dan at Telestream. Thanks very much.
Hello, this is Dan Murray with Telestream. Today I'd like to talk to you about creating an end-to-end monitoring plan and show some demo. When considering your monitoring plan, first consider your overall network. Do you have encoders and you want to monitor pre and post encoder? What about after the package or origin and before and after dynamic add insert? Will you have player analytics you want to aggregate? And at the encoder, is it a transport stream or 2110? By looking at all these measurement points and aggregating it together, you can do end-to-end analysis, look at the service assurance, video, audio, compliance, and MOS scores. Are your ads inserting properly? What about live as well as VOD workflows? And can you correlate that with client analytics? Now I'd like to jump into a demo. Would it benefit your operations team to be able to insert your own network diagrams to be able to view the network? Or you can look at thumbnail walls, and each thumbnail would represent an entire program workflow. You can see what's going on or if there's any alarms, and then click through to see an end-to-end workflow in a list view. This way you can see the encoder, pre and post, packager, and all the bit rates, and different quality levels and audio and all of these things all in one place. Add insert is very important. So is add insert working properly? Did you get enough avails? When the ads occur, are they correct? What are the quality? And be able to store those thumbnails and determine what's going on. When looking at a monitoring system, is it valuable to you to select one that can do live as well as VOD? These are just a few of the examples of things you can monitor, and thank you for your time.
Thanks, chaps, and hello, everyone. We're going to switch context now to another work item we've been doing in the Streaming Video Alliance inside the Advertising Working Group. So hi, my name is Murad Kimji. I am a solutions architect at Sky, and I want to talk about a common story we all face inside the world of advertising. So, an ad buyer rings up the company and says, oh, my ads haven't been fulfilled. What's the problem? We then are going to talk to the ad scheduler, and they say, well, we schedule it, it's not us. We then go ahead and talk to the ad manager, and they say, well, the ad manager says, no, it's not us either, we're serving ads. We then talk to the player team, they say, we haven't seen any ads on the player. We then talk to the app team and they say, well, we can talk to the ad manager. I don't see where the problem is. We then talk to the broadcast people and they say, well, we're inserting ad markers for you to consume, it's not us. And then we go and talk to the stream people and say, well, we got ad markers in the manifest, don't look at us. And then finally, the ad buyer gets really wound up and says, right, I want a refund because you have not served an advert as promised. And this ends up in people losing money essentially. So inside our working group, we thought, how could we address this problem? And we thought, well, the best way to try and solve it is first, let's monitor it better. So what we did out, we basically went inside and looked at how we could create a blueprint and an architecture to diagnose and monitor systems which have server-side ad insertion for linear streams. And the challenge is that all these different components that make up a solution don't always live in the same company, so it gets really hard to triage. So we thought, well, we can create a blueprint to how to monitor this stuff better on an operational point of view, then maybe it'll help solve all these issues basically by addressing the root cause and thus making a better service. So these are some of the problem areas we deal with. Duration of ads could be wrong. Ad creators could be hosted on a weird server in Timbuktu, and before you know it, it falls over every time there's loads of people trying to request the ad. Or scutty markers might fail. I mean, the idea is a lot can go wrong, basically, affecting the overall experience. So what we did was, together as a group, and as you can see here, some of the people involved, half of them were already on the QoE working group, but they helped out to try and prove out an architecture to help monitor ads better. So basically, this is the high-level architecture. So as you can see, this is your normal architecture for server-side ad insertion across a live linear stream. In this case, is HLS. So what we did was we started off with a basic architecture and then added additional monitoring layers. And just to give you an idea of how ad insertion works, markers are put in the original video stream. And then basically a video player makes a request for an ad treated stream. Server-side ad insertion components basically then read the original source manifest and then detect the ad markers. They then reach out to the ad managers to get the actual ads themselves and then splice it in a personalized manifest. Then the player starts and boom, plays a stream with ads inserted. So what we wanted to do with all these wonderful people is do some extensive monitoring on the video source, so that's the live video stream, put some probes watching the manifest. In addition to that, we wanted to make sure monitor playback issues on the actual player and then add some smarts around the actual quality of the adverts themselves to see if they're distorted in any way. We then thought, how can we trace it across all these different components? And the easiest way to do this was to basically enrich all the HLS manifests with a unique identifier. In this case, we choose to put in the creative ID and the ad ID, which is provided by a third party. And the idea behind this, if we put that information inside the manifest at source and put it through the whole end-to-end stream, then basically we can help triage where the actual problem is and thus the actual creative and where it was served and so on and so on. So what we did was we basically went to try and solve these user cases first and see how we can monitor and detect a problem in these different areas. First off, inside the actual video player being used, we can actually detect not only when an ad placement came in, but more importantly, the actual ID of the ad as well. And this is at the player. So this can report back to a dashboard and to an actual analytics dashboard to say, I saw a problem at this time for that user on that ad, and here's the ID. That same ID could be detected as well, actually within the transcode packaging area, and as well as in the actual probes themselves. So these probes not only monitor the source video, but the HLS manifest would go out to the end user before the actual server-side ad solution provider, which we had Conscope and Adobe, and then they monitor the manifest after them as well. And this was provided not just by Telestream, but by TouchStream as well. And then basically we could actually see queue markers failing inside the source and the manifest and see which manifest was failing. Was it the original one? Was it the one that went out to the CDN? Or more importantly, was it the actual manifest served by the ad server? In this case, Adobe or Comscope. And then we had SimWave as well helping us with actually looking at the quality of the ads Is there dodgy audio? And is there bad video quality? Then we put it all together and then inside a visualization dashboard provided by TouchStream. Now, the goal here was to show that you could have different vendors doing different parts of the chain and still monitor the same problem. So we have two different vendors doing the actual dynamic manifest creation. And then we have two different vendors monitoring the manifest as well to actually show that by doing this blueprint, it's not a proprietary solution. It's something which could be used anywhere, anyhow, across any vendor, which is one of the key things we wanted to try and prove, that you didn't need one person or one vendor doing it. You could do it with whatever you had. And then thanks to this POC, we recognize that we could catch a dodgy SCSI marker and report to the dashboard. We could actually find a dodgy ad creator being hosted on a server. And the server wasn't in Timbuktu, it was actually on a tin somewhere in a dodgy data center. Anyway, and then we could see if something fails and then alert and solve it. So that's what we did. And we think we did a good job doing that. But then what we want to do in the future is basically design better KPIs. We want to basically get the fulfillment data from the ad manager and integrate that into a dashboard as well. And then we want to make the actual perceptual quality metrics, as in bad audio, completely inside our ad chain, so that ads at source and at distribution are scanned for bad artifacts or bad audio. So kind of future work items where we wanted to take this further. The first thing we wanted to establish was an ad monitoring framework. And that's something which has all the KPIs and all the touch points, which we could then distribute to the actual industry and say, these are the key KPIs and touch points you should monitor in this fashion. Now, where we can do this, I mean, we spoke to the Dash If guys and talk about enriching Dash manifest with his unique ID and maybe work on a common way of doing that. And then we're speaking to people at adid.org, and even SIMT were interested in it as well. So there's lots of places we can go with this. I think what we want to do next is try and make this a reality in the ecosystem. And how we can do that? By basically getting your help as well. So look, if you're interested in any of the stuff we're seeing, come have a chat with us at the Stream Video Alliance. We're trying to make streaming better, and thank you so much for your time.